Hey guys, welcome to the NCEA Level 2 Calculus 2019 paper. In this video, what I'm going to be going through is the fully worked answers, letting you guys know what you need to do for achieve merit and excellence. The best way to watch this video is at the start of each question, pause the video, read the question, see if you can do it by yourself first, at least how far you can actually go with the question, and then watch the video just to see what grade you could potentially get. Cool. Without further ado, let's get started. So question 1 here, what we have is we've got a function and we've been asked to find the gradient of this graph at the point where x equals to 2. So what we are really asked in this question is we want to find out what f dash of 2 is. Now we've got f of x. So f of x is equal to x to the power of 4 plus 3x squared minus 17. So I need to differentiate this function. So when I differentiate this function, I'm going to get 4x cubed plus 6x. And once I found the gradient function, the next step is substituting the 2 in it, because that's going to give me what the gradient is. So we've got 4 times 2 cubed plus 6 times 2, which equals to 44. So this question is just worth an achieved, and you have to actually get the derivative found and the gradient evaluated. So there's no kind of like any kind of separate marks on it. So you've got to get the answer correct for this question to get an achieved. All right, so let's go to question B. Question B here, we've asked to find the coordinates of the point of the graph where the tangent to the curve is parallel to the line. Okay, so this is a little bit more to it, and the best way to go about this is just on the side here. I'm going to show you guys what it looks like, so it kind of makes sense. What you have is you've got a cubic right now. So the cubic generally looks something like this, and because it's a positive one, it's going to look, it's increasing, so that's fine. Now it's saying where the tangent to the curve is parallel to the line y equals negative 8x plus 6. Now what I want to do is y minus 8x. So I want to know what this equation of the straight line is going to look like. So if I do this, I'm going to get 8x minus 6. Now that means this 8x minus 6 is going to look somewhere there. We don't know where it is, but it's going to be somewhere there, right? And it could be even in the middle, we don't know. But what the question is asking is, when is the tangent parallel to the line? So that means you could potentially have two tangents that are going to be parallel to this particular line, because there's going to be two gradients that are there. Could be two, could be one, but we'll find out. So what we then need to know is our first step is we're going to be looking at this equation first to figure out what the gradient is. And we kind of have what the gradient of that line is, because that's actually equal to 8. So because the slope is 8, then what we need to do is work out what the gradient function is. So originally the function is this: f of x equals 4x cubed minus 4x plus 4. When we differentiate it, we are going to get 12x squared minus 4. And what we want to know is, when is this gradient function where the gradient is equal to 8? So what we're going to do is we're going to put down 12x squared minus 4 equals to 8. And if you're wondering where the 8 came from, 8 is the slope, the gradient of this slope, gradient of this line here. And then these lines, these tangents, are also going to have a gradient of 8 because they are parallel lines. So carrying on, we're going to try and figure out what the x value is. So we're going to get 12, 8 plus 4, and then we've got 12x squared equals 12, and then x squared is equal to 12 divided by 12, so x squared is equal to 1. That means x is equal to plus or minus 1. So we actually have two values, as you can see, because it's plus or minus 1. So that's the x value. And if you go back to the question's actually asking us to find the coordinates of the points. So what we just have the x values. We need to get the respective y values as well. So we're going to put down f of 1 So that means I'm going to get 4 times 1 cubed minus 4 times 1 plus 4. And that's going to give me 4. So that's my first point there. My first point is 1, 4. Then I've got my second point, which is f of negative 1. So I'm going to get 4 negative 1 cubed minus 4 times negative 1 plus 4. And now this is also equal to 4. And my second point is going to be negative 1 and 4. So I can kind of say that I've got 2 points here, 1, 4. So those are the 2 coordinate points where the tangent is parallel to that particular line, that the red line there. Okay, bit strange to see an excellence question coming up this early in the paper, but that is what they've decided. So derivative found and made equal to 8 gets you an achieved. So this part here gets you an achieved. Only one coordinate point found is going to give you a merit. So that means up to there. Both points found gets you an excellence. Yeah, like I said, I mean, it's very strange to see an excellence question this early, but you know, this is what they've decided to go last year. Okay, moving on to the next question. All right, so in this question, what we have is we've got volume of a balloon that's going up at some point, I'm guessing. Yep, so we want to find the radius of the balloon when the rate of change. Now, this is something important to understand, all right? It's asking when the rate of change of the volume with respect to radius. All right, now that basically just means dV dr. Okay, so dV dr, because this is where we're getting the V from, the volume is changing with respect to the radius. Now, if we want to find dV dr, we have to go to the volume of the balloon equation, which is 4 over 3 pi r cubed. And if we want to find dV dr, then all you have to do is differentiate this function here. So when we differentiate it, we are going to get 4/3 multiplied by 3 pi r 3 minus 1. Now, I'm doing this a little bit the old-fashioned way with putting in the rules, because just so that people can kind of keep up with what's happening. So then we're going to get dV dr is equal to 4 pi r squared. And if you look at the question's actually asking us to find the radius of the balloon when the rate is 25 centimeter cube per centimeter. All right, now that's something really important to understand, is that what you've been given there, now see how, let me just write this down separately here. So the 25 pi centimeter cubed per centimeter is the same thing as saying, now if you look at the centimeter cube, that's actually volume, and then the centimeter is r. So all you're looking at there is that dV dr is equal to 25 pi. So what I'm going to do is I'm going to replace the 25 pi with dV dr, and that's going to help me figure out what the radius is. So writing down 25 pi equals 4 pi r squared. And rearranging everything here, I'm going to get r squared is equal to 25 pi divided by 4 pi. Now my 2 pi's actually cancel out each other, and I'm left over with r squared is equal to 25 over 4, which means I can take square root of it, which is r is equal to square root of 25 over 4, which means r is equal to 5 over 2, or 2.5 centimeters. Okay, so in terms of grades for this question, derivative found and made equal to 25 pi gets you an achieved. So getting to this line here will get you an achieved, and then getting the final answer will get you a merit. All right, so let's go to the next question, guys. All right, now with this question, what we have is we are trying to actually figure out a quadratic function that actually has all these properties, right? So, but the thing is, we don't know what this quadratic equation starts out as, but what we do know is we can write down an equation of a quadratic as ax squared plus bx plus c. Okay, so those are all the things that we know about just a general quadratic equation. Now, if you look at that first bullet point, it says that when x equals to 0, it has a gradient of 7. So that means we know that f dash of 0 equals to 7. All right. Then it says a turning point when x equals to 1. Now, turning point means it has a gradient of 0. So we can then say f dash of 1 is equal to 0. And finally, it says a value of negative 20 when x equals to 4. So then we can say that f of 4 is equal to negative 20. Now, these are all these three little important information that's going to be useful for us in actually figuring out this particular quadratic. So we're going to use them one step at a time. So our first step is to find the derivative function. So we're going to derive this. So we're going to get f dash of x is equal to, now because a is a constant, we can then write this as 2ax. So we're pretty much following the same rules as differentiation. And then with bx, because b is a constant, we're going to put that just as b. And because c is a constant, it'll become 0. So we've got a derivative function. Now from here, we can actually start using this information here, all these information, to try and figure out what it is. So I'm going to use the first one, which is the yellow one here. And because I know that f dash of 0 is equal to 7, I can rewrite this as, I can substitute 7 is equal to 2 times a times 0 plus b. Now 2 times a times 0 is equal to 0. So 7 is equal to b. I've just figured out what the b value is. Now the next stage is I am going to use the second bullet point, which is f dash of 1 is equal to 0. So then I've got 0 is, whoa, let's try that again. So then I've got 0 is equal to 2a times 1 plus b, but b is 7. We've just figured out what that b is 7, so we can just leave it there. So then 0 is equal to 2 times a plus 7, and then 2a is equal to minus 7. And then finally a is equal to negative 7 divided by 2, or we can say that it's negative 3.5. So now we've figured out what a is, we've figured out what b is, and then finally we're going to use that last bit of information. So this is that second part of the information, and then our last information is f to the power of f to the 4 is negative 20. And now what we're going to do is, instead of f dash of x, we're going to go back to f of x. So f of x is equal to ax squared plus bx plus c. That's what we said it was. We figured out what a is, which is negative 3.5. We figured out what b is, which is 7x. And then c is what we're trying to actually figure out now. But using this point f of 4, negative 20, we can substitute it in now. So we can say negative 20 is equal to negative 3.5 times 4 squared plus 7 times 4 plus c. So what we have got here is, I'm going to need my calculator. What do we have? What do we have? Negative 3.5. So negative 3.5 times 16 plus 28 is equal to negative 28. All right, so then I've got negative 28 plus c, and then c is equal to negative 20, and of course 28, when it comes to this side, it becomes plus 28, which then leaves me with 8 as my c value. So what I've actually done is I've actually worked out what my quadratic equation is. So my quadratic equation then is equal to negative 3.5x squared plus 7x plus 8. And I think that's what the question actually asked us to do, is to figure out the quadratic function that has all of these three properties. Cool. So let's have a look at what you get for grades. Now, general form of quadratic with derivative found is achieved. So getting up to here gets you an achieved. With derivative found and made equal to 0, 7 equal to 7 when x equals, and made equal to 0 when x equals to 1. So you need to do both of these parts here. Even if you don't solve it, just putting the derivatives equal gets you a merit. General form of with derivative found and made equal to 7. Yep. So even if you don't find the value of a and b, but if you just write down those two derivatives, then you can get a merit. And then finally, quadratic found correctly is getting you an excellence. Okay, so let's go to the next question, guys. All right, guys, we're moving on to the next question here. So the next question, what we have is we've got two graphs and they just touch when x equals -1. So they have a common tangent at the point of contact. Okay. Use calculus to find the coordinates of the points. Okay, so what we have here is, I want you guys to think about it like this. Where we have. So we got g of x. All right, now that's a cubic. A cubic is going to look something like this. Then we've got h of x, which happens to be a parabola. Touch when it's -1. So it could look something like this. All right, I mean, this is a terrible diagram. This is probably not what it is, but I'm just trying to give you guys an idea here. And it actually says to us that it touches when x equals -1. So right there at that point, x equals -1. Okay, so use calculus to find the coordinates of the points of the two graphs. Now, these are the facts that we know. All right, so the facts that we know is that when if we put g of -1, whatever value we get for that, it's going to be the same for h of -1, the y value. Because think about it, at that point, both of these graphs have the same y value. So that means if we put -1 in the green equation or the pink equation, we're going to get the same value. So that's what this means. G of -1 equals h of -1. Now the other thing that's important also is to know that they both have a common tangent. If they both have a common tangent, then we can say g dash of -1 is also equal to h dash of -1. That means both of the gradients are going to be the same. So if that's the case, then our next step is to figure out what g of x is and h of x is. So let me write down what g of x is first. So g of x right now is x cubed minus ax squared plus 6. Then I could say that g dash of x equals 3x squared minus 2ax. And if I was to do h of x is equal to 2x squared plus bx plus 13, which means h dash of x equals, what do we got? 4x plus b. All right. Now the next step is we can actually write down what g dash of -1 is. So g dash of -1 is going to be 3 times -1 squared minus 2a times -1. So what we're going to end up with is 3 plus 2a. Because -1 squared is +1, and then -2 times -1 is +2. So that's how we get 3 plus 2a. And we're going to repeat that for h. So we're going to find out what h of -1 is, which is going to be 4 times -1 plus b, which means we're going to get -4 plus b. And now what we can say is because g dash of 1 is equal to h dash of -1, what we then can say is 3 plus 2a is actually equal to -4 plus b. And we're going to write that down here, because you can kind of see where this is going to lead into. This is going to lead into a simultaneous equations. So rearranging this, what we're then going to have is a quadratic, not a quadratic equation, like a linear equation, but I want to put all the a and b's together and the numbers together. So I'm going to get 3 plus 4 equals b minus 2a. Now, it doesn't matter if you guys do it the other way, so you're still going to end up with the same kind of linear equation. So I've got my first linear equation as 7 is equal to b minus 2a. And now what I need to do is I need to figure out what g of negative 1 is, and I need to figure out what h of negative 1 is, and then put them together. So g of negative 1. Once again, I'm going to have my g of x there. G of x is equal to x cubed minus ax squared plus 6, which means g of negative 1 equals negative 1 to the power of 3 minus a times negative 1 squared plus 6, which gives me, what have we got? We've got negative 1 plus a plus 6. Then what we need to do, I got it, something's not right there. I feel like it. Hang on, I know what it is. Negative 1 squared is positive 1, so negative a times positive 1 should be negative a. There we go, silly mistake averted. H of x, what was h of x? H of x is equal to 2x squared plus bx plus 13, which means h of negative 1 equals 2 times negative 1 squared plus b times negative 1 plus 13, which means h of x is now equal to 2 minus b plus 13. So because we said that g of negative 1 is equal to h of negative 1, we can then say that this 2 minus b plus 13 should equal to negative 1 minus a plus 6. And that's literally what we're going to do here. We're going to go negative 1 minus a plus 6 equals 2 minus b plus 13. And when we do this, we just need to rearrange everything so that we can actually figure out what it is. But we've got negative a plus 5 equals 15 minus b. I'm going to bring the b across to this side and 5 to the other side so that it becomes b minus a equals 15 minus 5. And so finally what I have is b minus a equals 10. So what I've set up now is that I've actually got two simultaneous equations, because here is one of my linear equation and here is my second linear equation, and I need to work them out together. So I'm going to write that down here. So I've got 7, wrong pen. So I've got 7 is equal to b minus 2a, and then 10 equals b minus a. Yep, so far so good. And so at this point what I need to do is I need to just eliminate them. So I'm going to subtract this. So 10 minus 7 is equal to 3. B minus b is equal to 0. Negative a minus minus 2a will become positive a. So just to kind of see that how it became, so we've got negative a minus negative 2a will become negative a plus 2a, and then you're going to get a. So once you get a is equal to 3, then we can say b minus a is equal to 10. So b minus 3 is equal to 10. And so we can say that b is equal to 13. Now guys, we're not finished with this question yet, because all we've done is we've actually just figured out what a and b is. So when we go back to the question, we are supposed to find, what are we supposed to find here? Let me show you guys. We're supposed to find the point of contact of the two graphs. So we're actually trying to find the y value and the x value. Now the x value we've already got, which is equal to negative 1. So we need to figure out what the y value is. Now it doesn't matter whether you use g of x or h of x. Either one is going to give you guys the answer. So I'm going to use h of x here. Actually, I might actually use both just to show you that it doesn't matter. So remember that h of negative 1, we wrote this as 2 minus b plus 13. And because b is equal to 13, we can say that 2 minus 13 plus 13 equals to 2. So if I use h of negative 1, then the point I get is negative 1 and 2. Okay, but let's say you use g of negative 1. If you use g of negative 1, then you're going to get negative 1 minus a plus 6. And because a is equal to 3, we're going to get negative 1 minus 3 plus 6. And as you can see, once again, you are going to end up with the same answer. So it doesn't matter which one you use, but as long as you find the point of intersection, and maybe just state it somewhere that this is the point of intersection, that part is important because you're communicating your answer. And so that's fine. So a few things in terms of grades wise. G of X and G of 1 is achieved. So that means we're looking at both of these things to get achieved, or both of these things. You need both of them to get achieved. So H dash of X and the gradient, or the G dash of X and G dash of -1 will get you an achieved. Derivatives, recognize they must be equal when X equals to -1, and recognizing that, okay, so doing this part here where you are, where is it? Maybe getting up to here is going to get you a merit, and also recognizing that they must be equal when -1. So getting up to here will also get you a merit. Simultaneous setups, two simultaneous equations are set up to find A and B. And okay, so basically excellence is the last point right there. Okay, cool. So that is it for question 1, guys. Now we go to question 2. Okay, question 2, I apologize that it's so tiny, but it's always like, let me just show you guys what it looks like. So this is the question here. You've asked to find out what the gradient function is and draw it below. Now it's really hard for me to do this in a tablet that it's in a landscape version, which is why I need to do it this way. But it doesn't matter, because in this one there's only there's some critical points that you need, and once you get the critical points, you're basically fine. So I always take a ruler and I look at the turning points. All right, now the turning points, there's one turning point there and there's a turning point here. So that means just get a ruler, and most of these grids, they should be set up in a way that they are below each other straight away. Okay, so, and this is literally, this is how I do it as well, guys. Whether it's if I'm in the test, I would be doing the same thing as I did here. So that point right there is turning point. Okay, that means at the gradient function, they're going to cross the x-axis. That's what it means. Now, if you look at it, this is another way to do this as well. Like right now, the cubic is positive here because it's actually increasing, and it's positive here because it's increasing, and it's negative after the turning point and up to that other turning point there. So that means we are going to get something like this. Is also, remember that this is a cubic, and when you differentiate a cubic, you are going to get a parabola, and this is a positive cubic because a positive cubic, and the parabola is also going to be a positive one. So that's the shape we're looking at. So if you look at it now, I'm going to draw up a parabola. What have I got? Between -3 and -2 and 4 and 5. Yeah, it's so far so good. All right, so I'm gonna do something along the lines like this, and notice how the parabola, it's in the positive side before the turning point and after the second turning point, and it's also negative between the two turning points. So just grades wise, this question, just bear with me here, because if you have an upright parabola with the x-intercepts lined up, turning points between -3 and -2, midway are lined up the steepest gradient, turning point. Okay, so you're going to get two, you're going to get a merit for this question. All right, now the first part is getting these two turning points correct. Now if you get that turning points correct, you get an achieved. All right, and then for the parabola itself, this little point has got to be between the two red ones, and it looks like you can actually get a merit because you're looking at the steepest part of the gradient in here, and the steepest part is somewhere around here. That's the steepest part, so that's generally where that it's going to turn back and go the other way. So yeah, so I mean, like the way I do these questions is that I actually look at the equation of the graph roughly, and then I know what the shape looks like when I differentiate it. So what I'm talking about is, like, I know that this is x cubed, and I know that when I differentiate it, I'm going to get 3x squared, and then I can just kind of do that as a graph. All right, so let's go to the next question. So the next question, what we have is we've got a derived function, and it says that it passes through to -25. All right, so we're trying to figure out what p of x is. So our step is that we've got p dash of x is equal to 5 minus 8x cubed, which means p of x is equal to 5x minus 8x to the power of 4, because it actually increases the power, and we also got to divide the new power. And of course, don't forget your plus c. And when we do this, we're going to get p of x is equal to 5x minus 2x to the power of 4 plus c. Now at this point, we've been given the point. The point is equal to 2, -25, which is the same thing as saying that p of 2 equals -25. So we're going to substitute -25 in now. We're going to get -25 equals 5 times 2 minus 2 times 2 to the power of 4 plus c. So we got -25 equals 10 minus 32 plus c. We got -25 equals -22 plus c. And then c is equal to -25 plus 22. So you're going to get c is equal to -3. So then we can say that p of x is equal to 5x minus 2x to the power of 4 minus 3. Now this question here, as much as it seems long, it's not a hard, like a merit question. I mean, it's simply integrating and finding the c value, so it will definitely be an achieved question. Okay, let's go to question C. All right, so what we have is we've got question C, and in question C, what we have is a cubic, and we also have a k that's a positive constant. Now a cubic, now this is a negative cubic because it's -2k squared, and because k is a positive constant, we know that this is going to be a negative cubic, which means it's going to look something like this. And it says use calculus to find in terms of k the range of values where the graph is increasing. Now looking at this graph, basically the graph is positive there, so that means it's increasing between those two values. We've already figured that part out now. So our next step is to kind of go about and actually prove it, all right? So there's two ways you can do this. One is you can actually find out where the turning points are and then justify that it's a cubic, therefore it's increasing. That's one way. But the other way we're going to be doing it is slightly longer, but not actually, it's not too long. It's just one extra step. So anyway, what we're going to do is we're going to figure out what f dash of x is first. So we got -2k squared x cubed plus 3k x squared plus 12x minus 55. And so we're going to differentiate this now. When we differentiate this, we're going to get -6k squared x squared plus 6kx plus 12, and the 55 ends up being a 0, so we don't really need to worry about it. So the next thing to remember is that when you say that the graph is actually increasing, then what you can then say is f dash of x has to be greater than 0. All right, that's what it basically means. When a graph is increasing, it's greater than 0. When it's decreasing, it's less than 0. So then we can say since f dash of x is greater than 0, we can say -6k squared x squared plus 6kx plus 12 is greater than 0. Now, looking at this, we have a quadratic equation, and we also got a common factor of 6. In fact, we're actually going to take out -6 as a common factor, which means we're going to get k squared x squared minus kx, and we've got -2, which is greater than 0. And I guess this part is the really important part, all right? You want to get rid of that -6 So you want to take the negative 6 to the other side and get rid of it. So you want to go 0 divided by negative 6. So then what happens is you're going to get x squared, k squared x squared minus kx minus 2. And because we are dividing by a negative 6 here, the symbol has to change this way. All right, now this is the important part which people kind of forget about it, is that just because you're dividing a number by a 0 with a number doesn't, it's still, you're dividing by a negative number. That means in an inequality, the sign will actually switch over. So once that's done, we've got k squared x squared minus kx minus 2 is less than 0. Now looking at this, we need to figure out those two values. What I was talking about earlier about the two different ways, from this point you can actually do it in two different ways. But the way that I've always worked with and I've always shown people is using the little parabola. And the reason I show that is it just helps visually to see what's actually happening, and then it's much easier to write the answers as well. All right, so what I've got to do is I've got to factorize this. Now looking at this, I can actually treat k squared x squared as the same kind of unit. So in other words, what is going to happen is I'm actually going to get kx minus 2 and kx plus 1. Now if you're not sure how I got that so quickly, imagine it like this. All right, like I'm just going to put it, let's see, I'm going to put one more line in there just for the people that if I felt that I went too fast. You could rewrite the k squared x squared like this, minus kx minus 2 less than 0. So then what you have is like the blue thing squared minus blue thing. So that's how I know that like I can separate it. This is just algebra, guys, and I did a couple of questions of this in the tutorials. Which tutorials was it? Like there's some quadratic equation tutorials that I've done. Just remind me in the comment section and I'll put it up there. But yeah, so it's what we end up with is kx minus 2 and kx plus 1, and then this is now less than 0. But remember that this is a quadratic, all right? And this is where we do that thing that we've showed you guys before. So you've got a quadratic, and then you're trying to figure out when is it less than 0. The time that it's less than 0 is in this zone here. So you've got to find out those two values, the two roots. So you've got kx minus 2 equals to 0, which means kx is equal to 2, and then x is equal to 2 over k, or kx plus 1 is equal to 0, and then kx equals negative 1, x equals negative 1 over k. Now negative 1 over k is obviously smaller than 2 over k, so we can then say that this value here is negative 1 over k, and this value here is 2 over k, and then straight away you can see the zone where it's going to be below that below the line where it's 0. So our final answer is going to be negative 1 over k, and x is between negative 1 over k and 2 over k. So this is one way of doing it, right? Now the second way of doing it, if I should be going through, is you could find these two values here. So 2 over k and negative 1 over k. And then we can go right back to that original cubic that we had actually drawn. Because we actually have our two values, which is 2 over k and negative 1 over k is our turning points. And then we can actually justify saying that because this is a negative cubic, and it's going to be increasing between negative 1 over k and 2 over k. So this is another way you could do it as well. So achieved. Derivative found and made greater than 0 is going to be an achieved. Merit is correct endpoints of intervals. So that's somewhere here. If you find the correct points, and then correct range and justification for the choice. So that's going to be your excellence there. Okay, so let's go to the next question here. So this is question D here, and what we've got in question D is we've got another one of these diagrams that we've got to draw, and we've actually got to integrate it. So as I said to you guys before, this is a straight line, right? So we know that this is going to be having an equation of, like, I mean, this is an x, right? So, and it's a negative x because it's actually pointed down. That means, roughly looking at what we're going to do, the f of x is then going to be negative x squared over 2. So we know the shape that we're going to get is a, what do you call it? An upside down parabola. So if it's an upside down parabola, it could look like this, it could look like this, it could look like this. So we need to figure out, man, there's got to be some way to actually kind of figure out where it's actually going to work with. Now, I've made a mistake here. I've not actually lined up the grids, but that's all right. Okay, it's not a problem. We're still going to have to try and figure this out. So what are some of the important parts that is actually telling us? All right, guys, so the first bit of information that's really important to us is this point here that says graph of the function passes through the origin at 0, 0. So this graph is going to be passing through 0, 0. Now, the second thing that we need to figure out is when x equals to 2, there is a turning point. So that means when x equals to 2, the line looks like this. That means along this red dotted line, there is a turning point, and it could be any, but it has to be above the x-axis, right? Because it's an upside down parabola. So that's something to remember. Now, because parabola is symmetrical, all right? Because it's symmetrical, the other time when it's going to cut the x-axis is going to look like this. So we can kind of see what that parabola is going to look like. It's going to look something like this. I'm going to put that little arrows there to edge out. Now, we can get an accurate answer here, to be honest, but I'm looking at the answer schedule, and the answer schedule is actually saying a couple of things. That's why I'm not getting too stressed about this. The answer schedule says this: inverted parabola going through 0, 0 and 4, 0. Yep, we got those two things, which means that could get you an achieved, or a turning point lined up with the x-intercept. That means this is our turning point that's lined up. So it's either getting the turning point or those two things. And if you get both of them correct, then you get a merit. Now, I want to show you guys while we're at here is how can we get an answer that's actually even more accurate. Could we say, okay, if you want to know how to get a really accurate answer, we've got y is equal to, I'm looking at this particular straight line here. It has a gradient. Let's see, it's 2. Whoa, where did it go? Sorry, just bear with me. 1, 2, 3, 4, 5, 6. Okay, so it has a gradient of m is equal to negative 6 over 2, m equals negative 3. Yep. So this equation has negative 3x plus 6 as its equation of the line. So now that this is the gradient function, so it's f dash of x. So if I integrate this, f of x, I'm going to get negative 3x squared over 2 plus 6x and plus c. And because this graph is actually going through 0, 0, we can say that therefore c is equal to 0, and then f of x is equal to negative 1.5x squared plus 6x. I can take the negative 1.5 out as a common factor, and I'm going to get x minus 4. And so you can see that where that x minus 4 comes in, and then your 0 is there. And of course, you can find out what the actual turning point is by putting f of 2. But again, that's not what you're expected to do in this question. You're just expected to draw a diagram. But I just wanted to show you guys how to do that anyway. All right, so let's go to question E. So guys, with these types of questions, the best way for me to actually understand is to draw a little diagram. So I have got a lovely little car, terrible wheels. Well, you get the idea. And so this car is now traveling at a constant speed of 28 meters per second. So that means at this point right here, velocity equals 28 meters per second. And then it's approaching a corner. The driver applies the brakes and decelerates at a constant rate of 4 meters per second. So if I say this is the corner, his decelerating, so the acceleration is going to be 4 meters per second squared until the car reaches the corner with a speed of 10 meters per second. So at the corner, the speed of the car is 10 meters per second. So we're going to put down t is equal to 0 here when he first applied the brakes. So, and we are trying to figure out what the distance from here to here is. So we actually need to figure out the equation for S, and then we need to figure out what, well, once we figure out the equation for S, we can actually do it. So what we're going to do is we've got acceleration is equal to -4. So from that, we can see that the velocity is going to be -4t plus c when we actually integrate acceleration. So we're going to go to that first information that we have. When t equals to 0, velocity equals to 28. So that means when it's 0, 28, we're going to put 28 is equal to 4 times 0 plus c. Therefore, c is equal to 28. So from here, what we have is that v is equal to -4t plus 28. So using this function, we can now work out the distance function, displacement function actually. So we're going to get -4t squared over 2 plus 28t plus c. So we can write that s is equal to -2t squared plus 28t plus c. Now I've got this equation for, what do we call it, s equals -2t squared plus 28t plus c, right? Now what I'm going to do is I'm actually going to put down s of t starting from where the car actually was applied, where the brake was actually applied. Now if the brake was applied at the starting point, then I could actually say that c is equal to 0, because when t is equal to 0, s is equal to 0, as s of t is, and I'm going to write that down, is from where car applied brakes. So if that's the case, then I can say that s is equal to -2t squared plus 28t. But I need to know how long it took the car to actually reach 10 meters per second. So that means I got to go back to my velocity equation. My velocity equation is -4t plus 28. And I'm going to put down 10 equals -4t plus 28. Which means I am going to get, I'm going to rearrange this, 4t minus 10. So that's going to be 4t equals 28 minus 10. And I'm going to get 4t is equal to 18. And t equals 18 over 4, or 4.5 seconds. So once I got that 4.5 seconds, then what I can do is I can take it back to the S equation, and I can put it as 4.5. So I had 4.5, and you can figure out what the distance the car has traveled. So I'm going to get -2 times 4.5 squared plus 28 times 4.5. Yes, I'm going to need a calculator for this. So what have you got? -2 times 4.5 squared plus 28 times 4.5. It gives me 85.5 meters. So we can actually say the car traveled. What was the question? How far the car was from the corner when the driver first applied the brakes. So we can say the car was 85.5 meters away. So guys, grades wise, finding expression for velocity by anti-differentiating. So that gets you an achieved right there. Just going to zoom this out a little bit. Gets you an achieved. Find general expression for S and solves to find the time. So doing this and this, both of these things will get you a merit. And then find the value of C and correctly finds the distance versus car. So that part there gets you an excellence. All right, guys. So that is question 2 done. Now we go to question 3. Okay, so going to question 3. All right. So question 3, what we have is we've got a remote control car. S of t is given to us, and so we need to find out the initial speed of the car. So if we're trying to find the initial speed of the car, we are looking for v of 0. So then a velocity function, when we differentiate it from s of t, we're going to get 6 minus 2t. and then velocity of 0 is equal to 6 minus 2 times 0, which equals to 6 meters per second. So grades wise, nice achieved question. The next question it says is, how long after leaving P does the car change direction? So for us to actually figure out how it actually changes direction is when the velocity is negative. All right, but first we've got to figure out when is it actually equal to 0. So we're going to figure out when is the velocity equal to 0, because that'll actually tell us that it's coming back to a negative. So if I say velocity of t, when is it equal to 0? We're going to put 0 equals 6 minus 2t, and rearranging it, we are going to get 2t equals to 6, and t is equal to 3 seconds. So that means the velocity is 0 at t equals to 3 seconds, which means after 3 seconds, the speed has to be negative. Therefore, it's actually coming back to the start. So we can say that after 3 seconds, speed is, well, you could say velocity is negative, but speed is negative, so car is heading back to P. So grades wise, finding velocity is equal to 0, just identifying it can get you an achieved, or getting the 3 gets you an achieved. But you need to actually explain this explanation to get a merit for this question. All right, let's go to the next part of this question. How fast is the car moving when it reaches P for the second time? Now to do this, we're going to need our original equation, which was 6t minus t squared. So S of t was 6t minus t squared. So we're trying to figure out when it reaches P for the second time. So that means S is equal to 0, because at P, S is equal to 0. So we're going to put 0 is equal to 6t minus t squared and factorize this. So we've got t and 6 minus t. Therefore, t is equal to 0, or t is equal to 6. But here's the thing, that's when it reaches P for the second time, but the question is actually asking how fast is the car. So we actually need to figure out when t equals to 6, what is the velocity? So we go back to our velocity function, which is 6 minus 2t. So we're going to put down v of t is equal to 6 minus 2t. And then we're trying to find the velocity when it's 6 seconds. So it's going to be 6 minus 2 times 6, which gives us negative 6 meters per second. Remember that the car is actually traveling backwards, and so not backwards, is coming back to P. That's why the velocity is actually negative 6. So we do need to write that somewhere and just say that car is traveling back to P at 6 meters per second. So grades wise, t equals to 6 when it reaches, that gets you an achieved. To find out that it's 6 and finds the speed as well. So you need to find the speed as well. And then you've got to interpret it. So you've got to write a statement again to actually get that merit. All right, let's go to question B. All right, guys, so with this question, what we have is the key information is right here. It says the sum of the length of the cuboid, which is this part here, and the perimeter of the square cross-section, which is this thing here. All right, so you're looking at that perimeter. So in other words, you've got this length, and then it's a square, and that's going to be a perimeter here. So what I'm going to do is I'm going to start calling them a few things. So that's going to be my length. That's my length there. And I've got my square-faced side, so I could call it x, width, whatever, height. Let's go with height. So that's height and height. Because they're all the same, we've actually got 4 h's. And remember that all of this adds up to 100 centimeters. So equals 100 centimeters. So that's what that one sentence means. The sum of the length of the cuboid and the perimeter of the square cross section is to be 100 centimeters. So we can write this as now L plus 4H equals 100. And we can also say something like L is equal to 100 minus 4H. Now we want to try and find the maximum volume of this parcel. So volume of a cuboid is equal to the base, which is length times width times height. Now in this case, the width is the same thing as the height. So we can say that it's going to be length times h. Or we can say that volume is equal to LH squared. And because we've actually written L in terms of h, we can get rid of this L and rewrite this volume formula as 100 minus 4h multiplied by h squared. So at this point, you've just got to expand the brackets. So we're going to get 100h squared minus 4h cubed. We now differentiate this. So I'm going to come back here. So when we differentiate this, we're going to get v dash is equal to 200h minus 12h squared. And we also know that the maximum happens when the gradient is equal to 0. So we're going to put this as 0. And we're going to say 200, just going to see 200h minus 12h squared. A good idea is probably just writing it somewhere here. V dash equals to 0 for max, just so that you're communicating with the marker. And then we've got, what have we got? We've got h as a common factor, so we can take that out. So we're going to get 200 minus 12h. Therefore, our two answers are when h equals to 0, or 200 minus 12h equals to 0, which we can then just rearrange. So we're going to get negative 12h equals negative 200, and then h is equal to negative 200 divided by negative 12, which actually gives us 16.66, what is it, meters, centimeters? 100 centimeters. So this will be h is equal to 16.66 centimeters. So now the question is actually asking us to find the maximum possible volume, right? So we've just discovered what h is. So we're going to go back and put in the volume equation. So we've got 100 multiplied by 16.66 squared minus 4 times 16.66 cubed. And you end up with a volume of 9,259, but I'm just going to double check that. So you got negative 200 divided by negative 12. Always a good idea not to round up your answers, guys. I know I'm writing it in my exam like 16.66, but in my calculations, I'm still going to keep this 16.667. So what I'm going to do though, I'm going to use the answer function. So I'm going to go 100 times answer, shift answer squared minus 4 times shift answer to the power of 3, and that gives me an answer of 9,259. Yeah, I'll take that. Centimeter cubed is what we want to be looking at. Now, it's really important, if you go back to the question, it says, explain how you know. I'm looking at this line right here. Explain how you know that your answer is maximum, not the minimum volume. I would say the easiest way to do this is doing the second derivative test. So with the second derivative test, all you have to do is find out what v double dash is. So v dash is equal to 200h minus 12h squared, and v double dash is equal to 200 minus 24h. And at this point, we're going to substitute h as 16.667. And we're going to find out what v double dash is. Now, if v double dash is a negative, then the point is maximum. So we can go 200 minus 24 times 16.667. And as you can see, we're getting a negative value, negative 200 point whatever. It doesn't really matter because all we really care about is the symbol. And then we can say that since v double dash is less than 0, it is a max. So simply saying that would be more than enough to get that merit. But I think, as I said to you guys, learn the double differentiation, because that's actually really useful. So if the double differentiation value is less than 0, it's a maximum, and if it's greater than 0, it's a minimum. Again, I've made a video for this. Just remind me in the comment section, and I could put a link up for it later. But you know, it's just when you make these long videos, you just forget about things. All right, let's go have a look at the grades. Set up equation for volume in terms of one variable and differentiates. So we're looking at somewhere around here to get an achieved. So getting up to this line here, you're looking at an achieved. Makes derivative equals to 0. Solves the quadratic for 2 solutions for x. So that gets you a merit. Well, except we didn't use x, we used h. That's fine. Finds corrects volume and justification. So we need the justification and the volume to get an excellence. Now in some cases they actually tell you don't need to justify, so just need to read the question, guys, just to see what it is that they want you to do. All right, let's go to the last question. All right, guys, so for this question here, what we have is we've got 2 points A and B, and they're on some random cubic graph that's going to look like this, where the tangent to the graph passes through the origin. Okay, so that's maybe not the best cubic. I'm just thinking, it's like, let's say we got a tangent like this, right? It's going to cut at 0, 0, maybe something like this. Okay, that's a different color. Just want to show you guys what the graph looks like visually, and then we can actually go from there. Okay, so let's say this point right here is the origin, 0, 0, and we've got 2 points, point A and point B. Now, that's all the information I've got given. Wonderful. Well, considering it's a calculus paper, we are going to differentiate the first thing. That's the first step we're always going to do, all right? So we've got x cubed minus 3x squared minus 4x. We're going to differentiate this, and we're going to get 3x squared minus 6x minus 4. All right, that's our gradient function. Now the second thing to look at is I'm just going to look at point B here. All right, so this point B is somewhere like this. So that's point B, and there's the gradient, and it's going to be cutting at 0, 0, right? So it's going to look something like this, where that's 0, 0. So this is point B. What I can say is I'm going to call this little b for now. If the x value is little b, then I need to figure out what the y value of little b is. So that means I'm going to put down f of b, which is going to give me b cubed minus 3b squared minus 4b. So what I've just done is I've actually figured out what the location for capital, like the b is, the big B, which is little b, b cubed minus 3b squared minus 4b. So that's the point right there. All right. Now I can also figure out what the gradient is using the f dash of x. So f dash of b will give me 3b squared minus 6b minus 4. Okay, so that's the gradient right there. Now looking at this, now here's where the little cheekiness comes from, is that because it goes through the origin, what we can then do is we can actually say rise over run is equal to the gradient. Yeah, because we know that the gradient is change in y divided by change in x. Now, the gradient itself, we know what the gradient is, because the gradient is 3b squared minus 6b minus 4. So that's that yellow part there. That's the gradient. So I'm going to write that down here. I've got 3b squared minus 6b minus 4 equals, looking at the change in y. The change in y is that, what have we got, that y value that we just discovered before, which is b cubed minus 3b squared minus 4b, minus 0, because remember change in y is y2 minus y1 divided by x2 minus x1. Now x1 and y1 is 0, 0. That's there, x1 and y1. And our x2 and y2 is there. So if that's the case, then that whole thing gets divided by x2 is b minus 0. Now we're starting to get somewhere. So we can actually write this as 3b squared minus 6b minus 4 equals b cubed minus 3b squared minus 4b divided by b. And of course now we can start getting rid of each one of those b's in the numerator because we're dividing it by b. This will become b squared minus 3b minus 4. So far so good. Then what we can do is we can rearrange this. So we can actually get rid of the b. No, we can't get rid of the b. What am I saying? So we've got 3b squared. B squared comes to this side, which becomes minus b squared. Then we've got minus 6b plus 3b. Then we've got minus 4 plus 4, and that equals to 0. So this really simplifies to 2b squared minus 3b equals to 0. So at this point we can actually factorize the b out. So we're going to get 2b minus 3 is equal to 0, and then we're going to get b is equal to 0, or 2b minus 3 is equal to 0. So in the second case we're going to get 2b is equal to positive 3, and then we can say that b is equal to 3 over 2. Now you're wondering, why did we get two values for b? All right, b is equal to 0 and b is equal to 3 over 2. Now, the reason why we've got two values is because if we go back to that original diagram, so notice how I did this whole, the green part here and then the pink part there and the green part there. That is actually reflected. It's reflected on the other side, and that's why you're getting two values. So what we've just discovered is the a and b value. So if I write the capital A, capital B, we've actually figured out what its x values are. So you've got 0 and then you've got 3 over 2. So now we need to actually work out what the y values for those things are. And to do that, we have to go back to the original function. The original function is x cubed minus 3x squared minus 4x. So I'm going to bring that down here. X cubed, what was it? Minus 3x squared minus 4x. Now when we put f of 0, that's nice because everything becomes 0. So the a value becomes 0, 0 itself. And then we've got f of 3 over 2. Gonna need my calculator for this. So we've got 1.5 to the power of 3 minus 3 times 1.5 squared minus 4 times 1.5. So I'm getting negative 9.375. which happens to be my second point. Now weirdly with this question, that's not all, because if we go back to the original question, it actually says find the coordinates of points A and B and the equation of each tangent. Man, this question just keeps giving, doesn't it? Okay, so we've actually got we've got the points A and B, but now we need to actually work out what the equation of the tangent is. So we've got to work out what the gradient is. Now we know the gradient function, that is 3x squared minus 6x minus 4. So the gradient at 0, what have we got? We've got negative 4, because 0 minus 4, we're going to get negative 4. And because we know that the tangent is actually going through 0, we can actually say the first tangent is going to be negative 4x plus 0, because we know that it's actually going through 0, so we don't need to worry about calculating the c value. Then we've got to repeat that again for 3 over 2. So this one, we're going to get 3 times 3 over 2 squared. I'm going to actually move that here, guys, just need that space. So f dash of 3 over 2 is going to be 3 times 3 over 2 squared minus 6 times 3 over 2 minus 4. So this gradient is now equal to, what have we got? I'm going to put this as 1.5. That's just 1.5 squared minus 6 times 1.5 minus 4, and it gives me negative 6.25 as the gradient. So my second tangent is going to be negative 6.25x. So somewhere I want to write down tangents are y equals negative 6.25x and y equals negative 4x. And I also want to say the 2 points are 0, 0, and 1.5 and negative 9.375. Ugly question, long question, but guess what? That's what they do. So let's have a look at what you need for achieve merit and excellence. Derivatives of f and make some progress. So if you find the derivative and you've done some sort of work towards finding that answer, you could get an achieved. Finds 1 point in the equation of the tangent. So that's pretty self-explanatory. Find 2. Okay, so if you find 1 point and a tangent, so 1 point and a tangent gets you merit. And if you get 2 points and both tangents, then you end up getting an excellence. All right, guys. So it was a bit of a long paper in terms of just explaining things. And these papers seem just to get a little bit longer to explain every single time because the questions are just a little bit more challenging. But we got there in the end. So yeah, my advice for you guys in this is quite simple. You know, with calculus, it's majority of the questions you got to differentiate or integrate. So you need to recognize which ones you need to do what for. There's always a question on kinematics, so learn that. And there's always a sketching the graph one as well. So make sure you kind of learn those little skills that to kind of help you out with boosting your grades. And as always, guys, I wish you guys the best of luck for this exam. And when it comes towards the end of the year, I will be running some tutorials for these papers. So do subscribe and tune in. And in saying that, that's it for this video. As always, I'm going to say this to you guys. Please like this video and share this video because there's a lot of people that needs these kind of help. And of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.